Model a function with an equation in a table. Today we're going to look at different problems where they're going to give us some words. We have to create those words and make those into a function or an equation, and then we also need to create a table from this, which is going to give us our x and y value. Let's take a look at this problem. My box over here on the right, this is my table. This table tells me two different points, and it gives me my x and y value, which are coordinates. So remember our ordered pair x and y. So I'm going to graph this at 0, 2, so I go to 0 and I go up 2. I'm going to put a point there, and then I have 1, 5, and then 2, 8. And 3, 11. Alright, so if I have all of these graphed and I put them, if I put down a straight edge, I should be able to line up every point and it should come in a straight line. So if I just wanted to find another point, I'd just put down that straight edge and I could locate any other point along that line. The other thing that I can do is that I can look at what is my difference between my y values. And if that difference is the same, which in this case it happens to be 3 for each one of these, if my difference is the same, then all I'm going to do is take y equals 3x. That difference is the same, so that becomes multiplication, so it's 3x. And then I look at this most important part, the 0 and 2, which means then when 3 times 0 needs to be 0, but then I have to also add on a 2. So it actually becomes y equals 3x plus 2. So if we take a look on the next slide, I have this equation graphed, and it gives me the equation y equals 3x plus 2. So again, it was my difference in the y values, so that was my 3. So that difference, because all of my x values are going up by 1, my difference is 3, so that becomes my 3x. And then my other important part is the x value is 0, so then my y is 2, so I am adding 2 there. Alright, let's take a look at another example. A car travels at an average speed of 30 miles an hour. So if I have the cars traveling at 30 miles an hour, that means I need to add for 2 hours, I'm going to add on another 30, so that drive distance is going to be 60. And then after 3 hours, it's 90 and 120. So again, I'm adding 30 each time. So because I'm adding that 30 each time, if I wanted to write my equation for this, y equals 30x, and if I drive for 0 hours, that means I'm going to go 0 miles, so I'm not going to add anything onto it, so it would just be y equals 30x. So then if I wanted to graph this, I would need to make sure that I mark what each value is going to be. So this is going to be 30. We're just going to go up here by 30s to make our graph easiest. Okay, so now I'm going to graph 130, 260, 390, for 120. So again, I should be able to lay down a straight edge, and all of these points should be, if I graphed it properly, all the points should lie right on that line. So here's what that graph would look like. And based off of this graph, we should be able to answer the question right down here at the bottom: how long does it take the car to travel 40 miles? So 40 miles is going to be between 30 and 60. So we know it's going to be between 1 and 2 hours to find our answer. Alright, we have another example. Graham needs to rent a wet saw from Home Depot. It is going to cost Graham $30 to rent the saw plus $8 per hour. Write an equation to model the situation and create a chart of the cost for the first 4 hours. Okay, so if I highlight what my important information is in this problem, I have the $30 and the $8 per hour. So then we need to create a chart for the first 4 hours. So if I create my chart, draw my box, split it in half, and we can call this X and Y. And then my values, let's just start off with 0, 1, 2, 3, and 4, because we want the first 4 hours. So after 0 hours, it's going to cost me $30 to rent it. And then after 1 hour, it's going to cost $38 because I have the $30 plus the 8 hours, or $8 per hour. And then the next one's going to cost me $46. And then I'm going to add on another 8. So if you notice here, I'm adding 8 each time. So 46 plus 8 would give me 54. And then the last one's going to give me 62. So again, if I was trying to write an equation for this, so I've made my table. So now if I want to write my equation for this, it would just be y equals, this number keeps coming up, so that's 8x, because it's $8 per hour, plus it's going to cost Graham $30 just initially to rent the wet saw. So my equation, y equals 8x plus 30. And you'll notice the two main numbers in the problem are a part of our equation. Looking at this next example, I think this would be a good time for you to pause the video and check to just see how you're doing, to see if you're understanding this and getting the right answer. Running costs for Mrs. Googly's car. So Mrs. Ganguly has calculated that it costs 55 cents a mile to run her car. Complete the function table below and write an equation for y in terms of x. Let x represent the number of miles and y represent the cost. Alright, so my x is going to represent my miles, and my y is going to represent my cost, which might just help me out with, okay, if Miss Ganguly travels 1 mile, that means it's going to cost her 55 cents. And if she travels 2 miles, that means it's going to cost her $1.10. And if she travels 3 miles, that's going to cost her $1.65. And then finally, if she travels 4 miles, $2.20 is my last value. And again, if I show what's happening here each time, I'm adding 55 cents. So because I'm adding that same amount each time, it becomes y equals 55 hundredths x. So I'm just going to multiply by the number of miles that I drive for my equation. Again, pause the video here and solve the problem, and then check your answer to see if you got it right. By noon, an ambulance has traveled 40 miles from its starting point and continues to travel at 55 miles per hour. Let t equal the travel time since noon. Write an expression to model the total distance the ambulance traveled. Use the expression to find the distance traveled by 2 p.m. So the first thing that I want to look at is what's my important information that I know in the problem. So I know it's traveled 40 miles and it's traveling at a speed of 55 miles per hour. Okay, so we also have by noon is when it has traveled. So if I look at this, I know that my starting point, so if I'm going to make my table here, I know that my starting point, so at 0 hours, my starting point is going to be 40 miles. So this will be t, and then d will be my y. So after 1 hour, if I'm traveling at 55 miles per hour, I'm going to add 55 onto the 40. So I'm adding 55 onto the 40, which is going to give me 95. So then after 2 hours, again, I'm going to add 55 onto that. So that's going to give me 150. So I added 55 on here. And then one more time, we're going to add 55 onto that. So that would be after 3 hours. So if I'm adding that on, that's going to give me 205. And then maybe if we just needed to, for some insurance, if we found after 4 hours, add again 55 onto that, that's going to give me 260. Okay, so my equation that I'm using is y equals, again, the dollar amount, or not the dollar amount, but the amount that I'm adding on each time is 55. So that then is going to become my value with x. And then I'm also looking at where my starting point is, which is at 0.40. So also it has traveled 40 miles. So plus 40 is my equation. Okay, so then the next thing that I would need to look at is if I want to answer that question B. So in order for me to do that, it says use the expression to find the distance traveled by 2 p.m. So I want to convert my time to actual time in the day. So if I look at this, it says by noon. So by noon, so anytime before noon. So this 0 is going to start off as my noon, and then from noon to 1, it's going to travel 55 miles. So then this becomes the 1 p.m. This is 2 p.m., 3 p.m., and 4 p.m. Okay, so all I have to do is go to my 2 p.m. time, and right there, the answer to B, 150 miles, which I should have answered with all of my work, so I didn't have to do any additional work. So that should conclude today's video lesson. The last question I have for you is, what does a turkey say? A gobble, gobble, gobble? A gobble, gobble, gobble. A gobble, gobble, gobble.